Hello students, this is lecture number 39 and we are into chapter number 10 and we are studying the beam bending. Okay, so we want to solve the beam bending problem. Okay. So far we looked at a beam which has some boundary conditions and equations. We found out the equation was d square m over dx square minus px equal to 0, where p is the loading, distributed loading like this one, m is the bending moment, and then we did further expansion of this term. So, we put m value there and we find out the final strong form was something like this: ei d square uy over dx square minus px equal to 0. Okay. And in order to solve that, we also found out the its weak form. Yeah, so this is a strong form, and we found out the weak form, and the weak form is something like this. So we have v, so wl, then vl, okay, minus w0 v0 plus dw over dx at x equal to L multiplied by m at L minus dw over dx at x equal to 0, m as 0, plus 0 to L px wx dx is equal to 0 to L d square w over dx square ei d square uy over dx square dx. So, this is the weak formulation we received. So, I have rearranged, I have made such a way that this term is equal to this term, meaning that this is all the force terms we have this side, and this is the which we will get this, and this will be of the form of k times u. We will get from here it will get f. So, from here to here will result into the force vector. This will be k times u vector, okay, k times u. So, where stiffness matrix multiplied by displacement vector. Okay. So, we have this weak formulation. So, we write weak form. Okay. So, we also have got, we said uy is a summation of ni, not summation of, but we wrote like n1, which is function of x, times u y1 plus n2, all n1 n2 n3 all are function of x only. So, u y2 plus n3x and theta 1 plus n4x times theta 2, okay, where Yeah, and also we can also have similarly w x as a function of this. So this is the test function. Yeah, so test function, and we also have the weight function, which will be like this only. So n1 x, let's call it w uh, w1, yeah, okay, then plus n2 x w2 plus n3 x, and let's call this one as v, okay, v1, okay, or maybe say let's call it phi 1, okay, I will explain what that means. Phi 1 plus n3, sorry, n4 phi 2, where phi 1 equal to dw over dx at x equal to 0, and phi 2 equal to dw over dx at x equal to L. Yeah. Okay, so that means this is also, if you know the w, you can just differentiate it, you can find out phi 1 and phi 2. So this is how it is written. Yeah. So this is also because theta 1 is du y over dx, right. So yeah, at x equal to 0. Yeah. Go same way, theta 1 equal to du y over dx at x equal to 0 given, and theta 2 equal to du y over dx at x equal to L. Okay. And we also derived the values of the expression for n1 to n4. n1 equal to, we got equal to 2 over L cube, and x plus L over 2, then x minus L square, n2x we got equal to minus 2 over L cube, x minus 3 L over 2, right, and then we get x square, okay. N3 x we got equal to 1 over L square, and the was x multiplied by x minus L square, and n4x equal to 1 over L square, then x square and x minus L. So this n we derived last time, so we can just use it now. Okay. So now everything is ready now. The only thing remains now is to use those values in the weak formulation, you know, and that's it. So let's put these values. So we already have the w at L is what? W at L is, we call it w2. W, so all this expression we can write accordingly, right. So we can write a w at L as so let's write that. Yeah. So in the weak formulation, we look at the values. So we have w at L, we are calling it w2, w at 0 we are calling it w1, right. Then dw over dx at x equal to L, we are saying it phi 2, and dw over dx at x equal to 0, we are calling it phi 1. Yeah, so so that means this value, if we put it here, so what we get? So what we will get is, see here, this is w2, this is w1, yeah, this one is phi 2, phi 1, and then we have like this one. So simply we can write like this one. So that means W L V L minus W 0 V 0 plus dw over dx x equal to L m at L minus dw over dx x equal to 0 m equal to 0 m at x equal to 0 will be equal to, we will have W2, yeah, so not W2, we can write like this W1, W2, phi 1 and phi 2. Okay, so this and multiplied by something here. So multiplied by W1 is this one. So this is the V at 0. So we write V 0, yeah, but minus. Then we have VL. Then we have this M at 0 minus M at 0. Yeah, okay, and then we have M at L, yeah, like this, yeah. So this we got like this. Okay, so let's write this as 1. So this we got equation. Now second part of this equation is this one. So we put W value here, and we have Px here. So what do we get? So Px, so let's go that side. So now 0 to L Wx times Px dx equal to 0 to L, and what we have here? We have N1 W1 plus N2 W2 plus N3 phi 1 plus N4 phi 2. This is what W is. So we wrote the W times Px times dx, right? Okay, so will be equal to, if you see here, this is just summation, so we can write it like this. It will be equal to W1 W2 phi 1 phi 2, yeah, and then we will have a forces, yeah. So we will have F1 F2, yeah, so F1 F2, and this is let's call it M1 M2, yeah. So this is the forces basically, or instead of writing that, let's write F1 F2 F3 F4 only. Okay, so where this number is just the row number, yeah. So like that, where, so where F I is equal to 0 to L Ni Nix Px dx. That's it. Yeah. So similar thing we got in other cases as well. This is actually the same way. So this is how you calculate. Yeah. So we get that. So this will be the force vector basically. Yeah. This plus the whatever we are getting from the boundary. This also. So this plus this will be the force vector. Okay, so we will do that later on. Okay, so now the third thing is 0 to L d square w dx square, and then ei d square ui over dx dx. And here we have two things basically. So here will be equal to, so let us write here rather, so 0 to L, and here so that means uh, we, uh, we will have d square n 1 over dx square times w1, right, and so on, plus d square n2 dx square w2, right, and so on. That will be for this one. Then we have ei, and then we have a similar thing for this, will be d square n1 over dx square uy1, and so on dx. Yeah. Okay, so this can be written as, like this, w1 w2 phi 1 phi 2 like this, and then we have the k vector, and we have here uy1 uy2, right, and then theta 1 theta 2 like this. Yeah. Okay. Okay. So that means what we are going to get from here is the stiffness matrix from here. So if you combine all of them, so let's combine this. So this is 1, this is this one is 2, and this is the third one. Yeah. And then what do we get combining them? So combining 1 plus 2 plus 3, okay, what will get? We will get this. So we have this multiplied to all of it. So this we can say is equal to this, we can say this is w, yeah, say this is the wt, this is k vector, and this is u t, right. Okay, so where this is a w vector, this is a k vector, and this one is a u vector. Yeah, in this case we can assume this is as wt. Yeah, here also we have this as wt. Yeah, so what do we get? We will get wt, yeah, and k u is equal to wt, yeah, and here we have the forces that coming from the, so minus v0 vl minus m0 ml, plus we have f1 f2 f3 f4 like this one. So let's call this combined WTF, and here what we get is after you get rid of the W transpose, you will get K U equal to F, right. Since since W is arbitrary, hence this has to be true, and where k is given by, so this is k, here we can say where k is given by, you can write where k, okay, let us write the end, okay, where k has k11, k12 and so on, k21 and so on, and this k is given by k ij is equal to, you can look at this and you can find out, right. So, this one is so there will be two terms. So, one coming from here, one coming from here. So, accordingly they will be multiplied and there is this one only. So, what you get is d square n I dx square E I d square n I over n j rather dx square dx. So, this is what it will be. So, n I here n j, so k I j is how this is calculated. So, this is from 0 to L. Yeah. So, this is what the stiffness matrix you calculate. You notice here that we have number degree of freedom like this one. So, we called it 1 here and 2 here, yeah, and then we called it the this one is number 3, yeah, and this one is number 4, yeah. So, this is how we arranged, and hence accordingly we have to put the values, okay. It is possible that your numbering is different, right. So, instead of doing that, you can also, you could have numbered this way. So, this is 1, this is 2, this is 3 and this is 4. And if you do that this way, then the accordingly you have to your n1 will be same as what n1 you took, n2 now will be similar to the old n3, and new n3 will be similar to the old n2, and n4 remains the same as earlier. That means 2 and 3 rows and columns will be interchanged. That will be the only difference, that is it. Yeah. So, in your book it may be that yeah, you have this numbering, yeah. So, but it does not matter as long as you know how you have numbered, and you will be fine. Just you have to follow the same number and accordingly you have to put, okay. Otherwise I mean this is not like universal. So, you can have your own numbering system and you can work that way, and it is going to the solution will not change. So, we will continue with this the old numbering, okay. So, however, just to remember that in your book the numbering system is like this one. So, accordingly you have to be careful that, okay. So, here the idea was to take your own like use your own numbering system, and it is all right basically if you use like this one, you know. So, as long as you understand is fine, okay. Okay. So, let us say if you want to find out the like k11, then what will you do? So, k11 will be equal to 0 to L and d square n1 dx square E I, and same thing here also. So, this will be basically a square of that and dx. Let us assume now, okay, assume EI equal to constant. Okay. For deriving K11, this may also vary along the length, okay, but for this particular example where we are going to calculate this K11, then we are taking the EI as constant. So, then what will be the value? So, we know that N1 is equal to 2 over L cube x plus L over 2 x minus L square. So, dN1 over dx is equal to, we get 2 over L cube, okay, and then x minus L square plus x plus L over 2 times 2 x minus L d square n 1 dx square is equal to 2 over L cube 2 x minus L plus 2 x minus L, yeah, plus x plus L over 2 times 2. Yeah. Okay. So, what do we get? We get this is equal to 2 over L cube, and we get 4 x minus L. So, we get 4 x minus L plus 2x plus L. So, 2 over L cube and 4x plus 2x 6x. So, we get 6x and then minus 4L, right, minus 4L plus L. So, minus 3 minus 3L. Okay. So, basically we get 6 over L cube 2x minus L. Yeah. So, this is what we get. Okay. So, dn1 over d square n1 over dx square equal to 6 over L cube 2x minus L. Yeah. So, this is what we got. So, that means K11 is equal to, we will get as 0 to L, EI will be in common, and we will also have this square. So, 6 over L cube square and then 2x minus L square dx. So, this will be 36 EI over L to power 6, and then this one. So, we get 2x minus L cube, oh, right, cube over 3 times 2 coming from this one. Yeah. So, we, yeah, and this is from L to 0. Okay. So, we get 36 EI over L6 multiplied by, put L here. So, we get L cube. So, divided by 6. So, 1 over 6, then L cube. So, L 2L minus L. So, L cube, then we put 0 here. So, that means minus L cube. So, becomes plus L cube basically, yeah, which is equal to 6. So, what we got here? So, we get this. So, we get 6 EI over L over 6 multiplied by 2 L3. So, 12 EI over L cube. Yeah. So, this K11 equal to 12 EI over L cube. So, this is what we get. Now, we can find out K12. Okay. So, if you want to find out K12, you can find out by using this formula d square n1 dx square EI d square n2 over dx square dx. Either you can use this one, or there are other way you can apply the mechanics. Basically, I mean the initially the direct displacement method that we looked at, right? So, direct stiffness method. So, this was for example, in this case, what is the meaning of K1? K11? K11 is like your, this is a beam and your degree of freedom is 1 here, 2 here, 3 here and 4 here. That's how we assumed, right? Okay. Now, K11 is when you apply a unit displacement here, you fix all of them. Yes, what you are doing is fix number 1, fix degree of freedom 2, 3, 4. Yeah. So, what you are going to do is you are fixing like this, and 3 also you are fixing. Yeah. So, 3 also you are fixing, meaning that the slope will be 0. Yeah. So, you will maintain slope equal to 0. Yeah. So, you will also say slope equal to 0 here. Yeah. Okay. And number 2 is apply unit displacement along degree of freedom 1. So, here you are going to give just one displacement. Yeah. Okay. So, how will it look like? This will look like something like this. So, here it goes like this, and this will be something like this. Yeah. Like this. So, what you see here is, here the slope is still 0. So, you can see, because we wanted the slope to be 0, so slope equal to 0. We have displacement from here to here is uy equal to 1. Yeah, and here this is fixed, because this is fixed. So, slope will be 0, and the displacement also is 0 here. Yeah. So, because this is fixed. Yeah. So, degree of freedom both have been fixed here. If that is the case, then K11 is the force. K11 is the force that you need upward, right? So, in that case, K11 is this, is the force you need upward to get this displacement. Yeah. So, this is the basic definition of the stiffness, right? So, okay. Now, based on that, we can also find out the other values. And what is the other values? If K11 is like this one, then we know that K12 will be like this. Yeah. So, whatever force we need to hold it, the K, similarly this one, this will be K, the moment you need to give this as unit displacement upward will be K13, and this will be K14, whatever the reaction which is produced here. So, these are the reaction forces which will be produced because of this displacement while maintaining all the boundary condition, meaning that degree of freedom, there is no displacement along degree of freedom 2, 3, 4. Yeah. So, all these are reaction forces. Yeah. So, remember all these are reaction forces. all these reactions. Okay. So then how can you find out K12, K13, K14? Well, we can do it. And how? Well, from here looking at that, so the idea is like this one, and then you have force K11, you have moment here K13, then you have force here K12, and then there is a moment here K14, and you know that summation of forces in y direction will be 0, hence K11 plus K12 has to be equal to 0, and hence K12 equal to minus K11, which is equal to minus the value of this, so 12 EI over LQ. So we write K12 will be minus 12 EI over LQ. So we can get based on the definition of the stiffness. Yeah. Okay, so we got K12 equal to minus 12 EI over LQ. So what is the next one? Next one we can find out these values. So now we know this value, now we have to find out this and this. Yeah. So second will be total moment equal to 0. Yeah. So total moment is equal to 0. Yeah. So let's say point A here and point B here. So we can take a moment about point B, and that will be equal to 0. Okay. So take about this point. So what do you have? So we have K13 and K14, both are there. So both are moments, right? K13 and K14. So we will write both are anti-clockwise. So K13 plus K14 are the moments, and then both are anti-clockwise, but K11 is giving clockwise multiplied by L. So minus K11 times L has to be equal to 0. Yes, this is a total moment. Yeah, there is no moment because of K12, because we are taking moment about this one, and this is passing through that point, hence there is no moment because of K12. So this is clockwise, so minus, this is anti-clockwise, hence both plus. Okay, so what we get? Or K13 plus K14 is equal to K11 times L, and that means we have 12 EI over LQ multiplied by L. So hence this will be 12 EI over L square. Now we could not get the value of these exactly. Yeah, so we could only, we know that the summation of these two will be equal to this one. That's, yeah, but we could not get the exact value, yeah, from here. Now that we do not have clear cut value of this one, so either we can find out K13 as 0 to L d square n1 dx square ei d square n3 dx square dx. Either you can do it like this way, or you can apply the mechanics further. And so far what we know, so the beam is something like this one, and you know that here this is K11, so which is equal to the force here is 12 EI over L cube, and the force here is this way is minus of this, means actually the force is like this one here. So here it is 12 EI over L cube. Yeah, and then we have this and this, and this we call it K13, this is K14. Now we can use the symmetry, right? So let's if you rotate this by 180 degree, then what happens? If you rotate by 180 degree, you will get exactly like this only, right? So if you rotate, see here, so rotate by 180 degree, yeah, and what we get? you will get exactly the same thing. Yeah, so this one is downward, so it will go this side becomes upward, and this is upward here, it will go here, I become downward. Yeah, so and this will be just interchanged. So the figure look like something like this. Yeah, and we will have here same thing. We will have 12 EI over L cube. Here we will have 12 EI over L cube, and then here you have K13 and here you have K14. Yeah, so because if you rotate it, this will not become clockwise. Anticlockwise will remain anticlockwise, and hence you have the anticlockwise. But the K14 will come here, K13 will come here. So what you see here, the force, this force, this and this configuration, looking at it, you can say that this and this are basically equal, has to be equal. Yeah, so this tells you because of symmetry. Okay, so because of symmetry, yeah, what you get, K13 is equal to K14, but you know that K13 plus K14 is equal to this one, so you divide by 2. Yeah, so what you get will be equal to 6 EI over L square. Yeah. Since this is equal to this, hence 2 of K13 is this one, so hence K13 alone will be 6 EI over L square, and that's what you get. Yeah. Given this information, okay, now we can derive the other values as well. So what we know so far is, if you have a force like this one, you have a slope 0 here, and you have a value from here to here which is equal to 1 unit displacement. Yeah, and the forces are 12 EI over L cube, 12 EI over L cube. Then there is this one moment which is 6 EI over L square, 6 EI over L square. Yeah. So you have this system like this one, and you know these are the real forces basically, meaning that if you apply a force here, if you apply a displacement in degree of freedom system 1 only, then the force that you have to apply here will be this, and along with that you have to also apply a moment of this, and since this end is fixed, because of this there will be this end moments and end forces which will be induced. Now if you look at the second in the second case, if you have to find out K22 for example, then how will you find out? We know that we have system as 1 here, 2 here, 3 here, 4 here. Okay, so that means that we are going to fix 1 and 3 here, we apply a displacement 1 here, right. So our system in that case will be like this, like this. So that means we are going to fix here and we are going to apply displacement of 1 here. This is the 1 displacement. So what you see here is just the mirror image of this. So what this is exactly mirror from here to go like this one, it goes like this one. So it's a mirror image. Right. So this is the mirror image of this, and what force we will get, just take from the mirror image. So value here will be, take this one, so this will be 12 EI over L cube. If this is like this, if this is like this one, then we have like this one basically. So we go like this, and this will be value 6 EI over L square, right. So this is the mirror image, hence if it is anti-clockwise, this will be clockwise here, but if it is down, it will be down only, because this is a mirror image, the mirror is like this, yeah. So from this side, so this side, yeah. So then this force upward remains the same, which will be 12 EI over L cube, and then this is anti-clockwise, so we will get the clockwise one. Clockwise, this will be 6 EI over L square. So this is how we will get, yeah. So remember that we had to find out K22 now, yeah. So if we want to find out K22, and our degree of freedom 2 is here, so K22 is 12 EI over L square. So what we are going to find out is K22 equal to, so we can write here, this gives you K22, yeah, okay, this gives you K21, this will give you K23, this will give you K24, means K22 is upward like this one, so hence it will be plus, which will be 12 EI over L cube. K21 will be, K21 is, see here, this is downward, hence minus, so minus 12 EI over L cube. K23, if you say clockwise, yeah, so minus, so K23 equal to minus 6 EI over L square, and this is also minus since clockwise, yeah, so K24, so K24 is equal to minus 6 EI over L square. Not to forget that all these we could have derived also, and just by doing Kiz equal to 0 to L integration d square Ni over dx square Ei d square Nj over dx square dx. Okay, so we could have done got the same value using this mathematics also. We have applied the mechanics, basically the big picture of the finite element analysis, something we did in chapter 2 as well. So same thing we are relating back, that these are basically springs only, and hence the forces are matching basically. Finally the law of physics will still hold here, so summation of forces has to be equal to 0, hence from here there you are getting. Okay, so based on whatever you get so far, we can now build it and we can see whether something is still required. So we have completed 2 rows and 2 columns, so remaining 2 rows will have only 4 components are now remaining, yeah. So that we will accordingly we can find out. So let's see. So here let's so far, yeah, so far let's write, so far big K is equal to, and we have like this, yeah, okay. We can write in common, we have Ei, so we can write Ei, okay, so Ei, and over L cube also you can write, right, okay, okay. And so we have like this one, let's write like this, and we have 1 2 3 and 4, 1 2 3 and 4, okay. So let's what we had here, so K11 was 12 Ei over L cube, so we write 12 here, and then minus 2 was minus 12, so this is minus 12, and then we get 6 EI over L square. So, we get 6 L here. So, 6 L and this also 6 L. So, see here in this case it is not summing to 0. Yeah. So, this is because we are mixing force and moments together, hence because of that. Yeah. So, there are two things are being here. We cannot add the moment to force because yeah. So, hence it is like this one. Okay. Okay. So, we get like this one, and this will be symmetric. Okay, regardless of this what you are seeing here, it is going to be symmetric. So, we will write same thing here. So, minus symmetric because from the equation you can see, right. So, equation if you see, if it is a 1 2 or 2 1 should give you the same value because of this. So, hence this will be symmetric, and here minus we get, then we have 6L. So, we get like this one. Now, the second one we get minus 12, and here we get 12, yeah, and then other we got minus 6I over L square. So, we write this becomes minus 6 6L minus 6L. Here also it will minus 6L, yeah, and minus 6L here. Yeah. Okay. So, we got this. Yeah. Now, only thing here we do not know what that is. Yeah. Okay. So, of course, this one what remains is here K33 and K44, K34. So, once we know that this will be equal to this, there are three things which are remaining. So, K33, K44 and K34, yeah, which will be equal to K43. So, there are three things we know, we have to know now. Let us find out K33 now, okay, and for that we have to find out. So, K33 equal to what? So, for that we have to find out d square n 3 dx square, where n3 as we know is equal to 1 over L square, and we have x minus L square. Yeah. Okay. So, that means d square dn3 over dx will be equal to 1 over L square, and then we have x minus L square plus we have 2x x minus L. Yeah. And hence d square n3 dx square will be equal to 1 over L square, and then 2x minus L plus 2x minus L plus 2x. Okay, so we have equal to 1 over L square, and then we have 2x minus L plus 2x. So, 1 over L square, and we have 4x. Yeah, so we can also write like this one. So, we have 2 here we can bring it common. So, we have 2 over L square and then 2x minus L. So, x here 2x minus L, 2 goes in common here. So, this is what we have. Okay, now K3 equal to 0 to L, and then we have a square of that. So, we have 4 over L4 and 2x minus L square EI dx is equal to 4 EI over L4 and 2x minus L cube divided by 3 multiplied by 2 coming from here, and this being computed from L to 0. So, is equal to 2 E I over 3 L 4 multiplied by, we have L here. So, we have L cube, and then we put 0 here. So, minus L. So, plus L cube again. So, we get 4 E I. There seems to be something wrong here, because answer cannot be like this one. So, let us see. So, this is like this. Okay. So, yeah. So, here if you see, this should have been 2 plus 2 equal to 4 here. So, okay. So, we need some correction there. So, write 4 here, and we have 2 common. So, we get 3 here. So, 4 plus 2 is 6. So, 2 times 3, and minus, we have 4L, 2 from here. So, minus 4 is minus 2. So, we get 3 here, 2 here. Yeah. So, let's make it like this, 3 here and 2 here. Yeah. So, 3 here, 2 here, right. Okay. 3 here and 2, and here we get divided by 3 and multiplied by 3 here. Yeah. So, we get like this. Okay. And here we should get 3 times 3, 9. So, here 4 over 9. So, let us write here, this we should get 4, this we will have 9. Okay. So, 4 here, 9 here, EI L4, and here if you put L here, then we get, if you put L here, so 3L minus 2L, so we get L cube. So, this is correct. And in 0, put 0 here, then minus 2L to power 3. So, 2 times 2, 4 times 2, 8. So, plus 8L. So, this will be 8L cube. So, what we get is 4, then 9L square, right. So, we will get here 4EI 9L4 multiplied by 9L cube. So, the value what we get here will be 4EI over L. Okay. So, this is K11 that we get 4EI over L, and this along with K1 2. So, we have these values as well, right. So, 6 EI over L square, and here we are getting 4 EI over L. So, 4 EI. So, 4 here we get 4 EI over L. So, L square. So, we get here L square. Okay. So, we got this one. Now, what is the value here that we have to find out? So, this we can make out. So, so far we have this situation. So, what situation? We have something like this. Yeah. So, this is one which is we need force upward. Yeah. And then here what is the value of this? So, first of all, this situation is where slope is equal to 1. Yes, this theta is equal to 1. Yeah. And all other displacements are 0. So accordingly we have in order to implement that, what we have 6ei over L square is the force upward, 6ei over L square. So 6ei over L square, and here it is downward, 6ei over L square. Yeah, then in order to do that we need this K2 K33, sorry, this is K33. So what we found out here is K33. So K33, which is equal to 4ei over L. So this is the moment which is applied here to get this angle equal to 1 unity, and reaction forces are produced. This one, this is this one, this is as per here, right. So these are the values. At 1 you get upward 6ei over L square, here it is downward, and then this is 4ei over L. So here we want to find out. So what value we have given so far is this is from K31, this is we are getting from K32, yeah, and then we have this value here which will give at K34. We want to find out K34, right. So we again we say point A here, point B. So moment about point B has to be equal to 0. So we can use this mechanics to find out K34, and so what we have, we already have this in balance. You can see the upward forces is equal to 0, this upward is downward, only moment we have to see. Yeah, so what we see K33 which is anti-clockwise. So 4ei over L plus K34. So we get these two anti-clockwise, and then we are taking moment from here. So there is no moment because of this, but there will be moment because of this, which is clockwise. So we take minus. So minus 6ei over L square multiplied by L. So from here to here. So this is going to create negative moment, and because this will be equal to 0. Yeah. So what we get? We get from here K34 is equal to 6ei. What we get? We get 6ei over L from here minus 4ei over L. Yeah, or what we get, or this tells you that K34 is equal to 2ei over L. So of course you could also have found out K34 as 0 to L d square n3 over dx square ei d square n4 over dx square dx. Yeah, so but from mechanics also you can find just like we have done here, and the value will be equal to 2ei over L. So we can write it here 2ei over L, meaning that we have to write here 2L square. Yeah. So see here this 2L square multiplied by ei over L cube. So that means 2ei over L only. Yeah. So 2ei over L. Okay. So since this is symmetric, so this we will get here too. So we have 2L square. So now what is value? What is the value of K44? Yeah. So in order to know K44, we can use this also, the way we do, right? Kij equal to formula also we can use, or we can also look at what is the meaning of that. Now the meaning is this. So now in this case what happens is we are interested in finding out what is the like we will give, for example, here we have unit displacement, here also we are going to give unit displacement. Yeah, so we will have something like this. Yeah, like that. So we have given unit displacement here, this is degree of freedom 4, and we are giving angle 1 here, and because in doing that we have to the forces, right. So you can see the forces we have. So you look here, so far we have this one. Yeah, so 2L square we have here, this and this. Okay, so here we got 6L which is upward, and then this is downward. So so value that we are getting here is 6 EI over L square. Here we have 6 EI over L square which is downward. Second one is minus, so hence we get downward this 6 EI over L square minus, and this 2 EI over L is the third. Along the third degree of freedom, is this. Yeah, so this is third degree of freedom. So we have this which is 2 EI over L. Okay, so we have this force acting, this acting downward, and we have to find out this. This is K44. Yeah, because fourth degree of freedom we have the angle, all other are basically restrained to 0. We have to find out K44. So from here we can find out. Yeah, so moment B equal to 0 we can do, and hence what we get, hence we are getting K44 which is like this, right, plus 2 EI over L. Yeah, okay, and then you have this is going to be clockwise, so 6 EI over L minus 6 EI over L square multiplied by L which will be equal to 0, or K44 will be equal to, you can see here, this will be 6 EI over L, this is 2 EI over L, so 2 minus 6 will be minus 4, hence K44 will be 4. So what we get is 4 EI over L. Yeah, so value we get of K44 is 4 EI over L. So this one we can write here. So we get 4L square. Also you can also see that both are basically same. Yeah, so that really means you could have also derived this based on this. So if you rotate this by 180 degree, you will get exactly this one, right. So you rotate like this one, so this goes this side, fixed goes this one, this is now upward, this is downward, hence exactly 180 degree rotation what you get. Yeah, so hence the values, whatever value you are getting here, same value will appear here in the same direction basically. Yeah, so that way also you would get that this K44 has to equal to K33 only, because this can be got exactly by rotating by 180 degree. Yeah, so this K33 and K44 will be the same in that case, and hence this will be equal to 4 EI over L. So that also we could have done. Okay, so here we finally derived this stiffness matrix for the beam. Yeah, so this is what the stiffness matrix is. Rest is just to solving the problem basically, right. So so we got the stiffness matrix, we know how to form the force vector, and we know the displacement vector, right. Displacement vector are, so we have Ku equal to F, and where U is equal to, in this case will be u y1, u y2, theta 1 and theta 2. Remember, so this is like this one, yeah. So u is arranged like this one. That's why you have like this. If u1 is here, if theta 1 goes here, then accordingly the whole row, this row should go there, yeah. So this row you have to make the second row, and this third row, this third sorry, this third row will be second row, and this third column becomes the second column, yeah. So you have to do if in case you are interchanging this one, right? So in the book you have u y1, then theta 1, then u y2, then theta 2. So you can get the stiffness matrix corresponding to that in the book just by interchanging these two columns and these two rows. You will get that, yeah. So that is all for now. Okay, so in the next video lecture we will solve some problem.